It's the exponent to which the base must be raised in order to get the number, okay, to generate the number. So based on this definition, what can we say should be the value of the following entities? Log of a to the base a, 1. Log of a number to the same base is always 1. Okay. Log of a number to the same base is always 1. Similarly, this would be minus 1. Log of a number and its reciprocal is always minus 1. Log of the number 1 to any base a, 0. 0. These are some standard values that you need to remember. Log of a number to the same base will be 1. Log of a number to its reciprocal will be minus 1. And log of 1 to the base, any base, is always 0. Like for example, okay, what will be value of log of cot 15 to the base tan 75? What would be the log value of cot of 15 degrees to the base of tan 75? One, yeah, minus 1. One. Can we write cot 15 as tan of pi by 2, 90 minus 15? Tan 75 हो ना? Log of tan 75 to the base tan 75. 1. Again, what be, let's suppose log of root 3 minus root 2 to the base of root 3 plus root 2. Log of root 3 minus root 2 to the base root 3 plus root 2. Minus 1. How do we get that? Rationalize. Root 3 minus root 2 into root 3 plus root 2. You can make us this simple thing. What is the value of this if we multiply? A plus b, a minus b, a square minus b square. But a square minus b square is like 1. Okay. So the two numbers are multiplicative inverse. So from here we can say that root 3 minus root 2 is 1 by root 3 plus root 2. So value would be minus 1. Similarly, what will be the value of log of sin pi by 2 by tan to the base tan pi by 3? This would be 0. Why so? How much is pi by 2? 90 degrees. Sin 90. 1. Log 1 is always 0. Is that comfortable here? Yes? Okay. Moving on. Fourth property. Now from here the actual properties of log that will be useful for problem solving will start. Log of AB to the base C. If we have a product of numbers inside the log of AB. So this is like writing log A to the base C plus log B to the base C. Log of a product splits as a sum. Log of a product splits as a sum. Like everything we discussed would be done with the proofs. So why would this property be? How do we establish that this would be it? So let's suppose, in order to prove this, let's assume that the value of this entity is x, the value of this entity is y, and the value of this entity is z. X, y, z. Just for a moment, let's assume that these are x, y, z. So from here, what will the exponential form of this? C to the power x is AB. That is what we mean. What will the exponential form of this? C to the power y is equal to a. And exponential form of this? C to the power z is b. You know, this would be the left hand side, this would be the right hand side. Okay. Now, if you multiply the two, what do we get? C to the power y. What happens to c to the power y into c to the power z? C to the power y plus z. You know, c power y into c power z is c power y plus z is equal to ab. But from the first equation, what do we have? AB is equal to c to the power x. So comparing the two, we get c power x is equal to c to the power y plus z. But if we have two numbers to the same base, the two numbers are equal with the same base, what must happen? The powers must be equal as well. If the bases are the same, the powers must be the same. Therefore, x is equal to y plus z, which is basically what we have to prove. X is equal to y plus z. Okay. So the first property that we have for log is log of a product splits as a sum. That's what you need to remember. Log of a product splits as a sum. Okay. Next property, log of a by b to the base c is log a to the base c minus log b to the base c. Log of a ratio splits as a difference. Log of a by b is log a minus log b. And how will you prove this? Same way. Okay, just follow the proof. Again, let's say we take this as x, take this as y, and take this as z. So these two will be the same as this. The only thing that changes is that in this case, c power x would be a by b. Just follow the same, right? Instead of having a ab, this case we will get a by b. So how do we create a by b? We divide. Okay, if we divide the two, what do we get over here? C to the power y minus z is equal to a by b. But a by b from here is c power x, which will give us what over here? C power x is equal to c to the power y minus z. I hope everyone is able to follow the notations. Okay, and then that will generalize with as x equal to y minus z. Okay, the two sides are equal with the same base. The powers must be the same. We can prove it in the exact same way as we did the earlier part. No need to write again. Does anyone follow this? Okay, moving on. Next. Log of a to the power b to the base c. If we have a power inside the log, log of a to the power b to the base c. Now, then what will happen to the power b? The power b will jump out of the log. power b will jump out of the log. That's like saying if we have log of 2 to the power 6 to the base 3. So what can we write this thing as? This power 6 will jump out. So you take 6 log 2 to the base 3, something like this. Any power inside the log, power in the number will jump out, comes out in the numerator. What is the proof of this? The proof of this property is basically this property. Can we say that a to the power b is like a into a into a into a written 3 times? Say a cube ko can we write a cube as a into a into a? Okay. So if we have a log of a into a, what will it end up becoming? Log a plus log a plus log a written 3 times. But what will be log a plus log a plus log a? 3 log a. Is anyone able to follow this? The proof of this property is basically an extension of the property 4. Okay. Property 6 is an extension of property 4. Is everyone okay with this part? That's like saying a to the power b can be written as a into a into a into a written b times. Yeah. But every time we have a product, what will the log convert to? The log will convert to a sum. So log will then end up becoming like log a plus log a plus log a written b times, which would be b times log a. So the power of the number comes out, it will jump out in the numerator. Okay. If we have a log a and the base is raised to a power, the base is raised to a power, the power of the base will come out in the denominator. The power of the base comes out in the denominator. Okay, let's do the proof for this. Again, same method in the proof. Let's assume that this entity is x and this entity is y. So what is the exponential form of the first part? C to the power b raised to the power x. A is equal to c to the power b raised to the power x. Okay. If we say that this is equal to x, converting it in the exponential form, the number would be the base raised to the power of the exponent. And what do we get from here? This is a is equal to c to the power y. Does anyone follow this? Okay. So now, since both of them are values of a, what must happen? They must be equal. So we get c to the power b to the power x will basically become c to the power bx. So c to the power bx is c to the power y. And we're using the same idea. Equal numbers with equal bases. What must happen? Powers must be equal as well. So that gives us x is equal to y by b. X is equal to y by b. So that is basically this. X is equal to y by b. Yeah. The power of the base comes out in the denominator. That is the general rule. Now then, combining these two results, we generate a new property 7, which is like if we have log b to the power p to the base of p by q, power of the number will come out in the numerator, power in the base will come out in the denominator. So p by q log of b to the base a. Okay. Is it okay with this? And now this will give rise to an important application. This property will give rise to an important application, which will be like, write down, in a log, if the number and the base are raised to the same power, then the value of the log remains same. In a log, if the number and the base are raised to the same power, the value of the log remains the same. Okay, now what we mean by this is, suppose we have a scenario like this. Log of 5 to the base 3. We have a number, log of 5 to the base 3. Now we take the number, we take the base and square both the sides, square both of them. What will we get? Log of 25 to the base 9. ये number और base का square कर दिया. Log of 25 to the base 9. What is the relation between these two numbers? They would be equal. Why? Because we can write 25 as 5 square and 9 as 3 square. Then according to this property, what will happen? The 2 of the number will come out in the numerator. The 2 of the base will come out in the denominator. Essentially, cancelling off, what are we left with? Log 5 to the base 3. Okay. Log of 125 to the base 27. Still be the same. 125 is 5 cube, 27 is 3 cube. The cubes comes out, they cancel off. What are we left with? Log 5 to the base 3. Okay, this would work in the inverse powers as well. So like that would be the same as saying log of 1 by 5 to the base 1 by 3. Work in this way as well. 1 by 5 is like 5 power minus 1, 1 by 3 is like 3 power minus 1, both the minus 1 come out, cancel off. So as long as the number and the base are raised by the same power, the power could be anything, positive, negative, blah blah blah, whatever. But as long as the number and the base are raised to the same power, what will happen to the value? It will remain same. The value will remain same. Is this okay to everyone? Okay. We'll quickly discuss some questions based on the formulas that we've discussed so far, the properties that we've discussed so far, before moving on. Question 3. Now, based on the stuff that we have discussed, find the value of log of 128 to the base 8. Find the value of log 128 to the base 8. This is based on the last property that we did. 8 by 3. 7 by 3. What can you write 128 as? 2 to the power 7. And what can you write 8 as? 2 cube. Okay. So this is log of 2 to the power 7 to the base 2 cube. And then what will happen in this? 7 will come out in the numerator, 3 will come out in the denominator. 7 by 3. बचा क्या? Log 2 to the base 2. The value of log 2 to the base 2? 1. Number is the same. Number in the log. If number in the base are the same, the value is 1. So what will be the value? What is the answer that we get? 7 by 3. Okay. Okay. Similarly, tell me the value of this. Log 3. Log to the base 3 of log 27 to the base 3. ये भी सिंपल सा क्वेश्चन है. Correct. What is the value of log 27 to the base 3? What should be exponent be on 3 so that it becomes 27? 3. So इसका जो value आ जाएगा 3. That's like log 3 to the base 3. But now what would be log 3 to the base 3? 1 again. Okay. Next question. Prove that log of 1 plus 2 plus 3 is log of 1 plus log of 2 plus log of 3. If you look at the properties, what is the related property? What should we have over here so that we can split it out as a sum? यहाँ पे क्या चाहिए? What do we need over here? Product. We need the expression in the form of a product. Log of a product splits as a sum. But given क्या? Log of a sum. So what should we do in this question to get it done? So Joe, what will be the trick in the question? Say it. Look. Yes, exactly. The simple thing is, how much is 1 plus 2 plus 3? 6. So this is like log 6, but then log 6 can also be written as log 6 was, but log 6 can also be written as log of 1 into 2 into 3. 1 into 2 into 3 is also 6. And now that we have it in the product form, what can we do? Split as a sum. This is log 1, log 2, log 3. Again, next question number 5. If A, B, C are 3 numbers in a GP, are any 3 consecutive positive integers? Are consecutive positive integers. If A, B, C are consecutive positive integers, prove that log of 1 plus AC is twice of log B. If A, B, C are consecutive integers, consecutive positive integers, prove that log of 1 plus AC is twice of log B. Yeah. If A, B, C are three consecutive positive integers, prove that very simple question here. How do we use the fact that A, B, C are three consecutive integers? Can we say that A in that case would be like B minus 1? And what we see? B plus 1. Consecutive integers, no? For like we do for all provings, we start with left hand side. We start with the left hand side. Okay, the left hand side is log of 1 plus AC. But considering that A, B, C are three consecutive integers, this is like writing log of 1 plus A is B minus 1, C is B plus 1. Now what happens to B minus 1, B plus 1? B square minus 1. So log of 1 plus B square minus 1 1 cancel हो गया. What are you left with? Log B square. And what can we write log B square as? 2 log B. Properties again. Does everyone follow this? Okay, next question. If x, y, z are three numbers in GP, then prove that log x to the base a plus log z to the base a is 2 log y to the base a. If x, y, z are three numbers in GP, prove that log x to the base a plus log z to the base a would be twice of log y to the base a. Again, we start the same way that we do. Start the left hand side. And if you have a log x to the base a or a log plus log z to the base a, how can we club this? Can we say that this is log of x into z to the base a? We can use the property in the reverse way as well. Log x plus log y would be log of xz. Log x plus log z would be log of xz. Now, if a, x, y, z are three numbers in GP, what is the related property? Y square would be equal to xz. This is something that we read in the first half. So xz के जगह पे what can we write? Y square. So this is log of y square to the base a, and y square is basically 2 log y. Isn't clear with this? Everyone's finding it comfortable, right? Any problems with anything? Okay. Next. Question number 7. If log A by B minus C is log B by C minus A is log C by A minus B, then prove that A to the power A into B to the power B into C to the power C is equal to 1. Prove that A to the power A into B to the power B into C to the power C is equal to 1. And we have a log of log A by B minus C is log B by C minus A equals to log C by A minus B is like a classical ratio proportion question. Okay. What is the general method of solving all ratio proportion questions? Equal to K. Yeah. So we use the same method. Let's suppose this is equal to K. Let. So then from here, what's the value of log A? K times B minus C. What's the value of log B? A times C minus A, and log C is A times A minus B. So now we have the value of log A, log B, log C. But use karte. The expression that we have to prove doesn't even have a log. So where do we use this? So in order to be able to use the set of values that we have over here, what we do is we make a slight change in the expression that we want to prove. Okay. What are we required to prove? A to the power A, B to the power B, C to the power C is equal to 1. Now let's say we do this. We take log of both sides. Just like we do a squaring both the sides, we take log of both the sides. Log is also an operator. Okay, just like we squaring both the sides, cubing both the sides, log is also an operator. Okay, it's not a value, it's an operator. It's a mathematical tool, a mathematical operator. So we take log of both the sides. So what do we get? Log of A to the power A, B to the power B into C to the power C is log 1. What's the value of log 1? 0. Log 1 is 0. We did that part as well. So this will come out to be 0. Yeah. Isn't there with this? So the idea is proving this is the same as proving this. Even if we are able to prove this result, उससे भी काम हो जाएगा. Is everyone okay with this part? Proving this would be the same as proving this. Now the advantage we have in proving this is we have a log term, so we will be able to utilize these values. Okay. So now let's suppose this is our target. So we start with the left hand side. What's the left hand side? Log of a to the power a, b to the power b, c to the power c. How do we simplify? How do you simplify the entire thing, the structure? Okay, to begin with, it's a product. What happens to log of product? Splits as a sum. So this will end up becoming log of a to the power a plus log of b to the power b plus log of c to the power c. But then that shows us that every number inside has a power. What happened with that power? All the powers will jump out. Okay. So this A comes out over here. This B comes out over here. And this C comes out over here. Now plug in the value of log A, log B, log C and simplify. Make this into this AB here. This will cancel with this and this will cancel with this. So when you plug in the values and simplify, you will observe that all the terms get cancelled off and you are left with the value 0, which is basically good enough. Okay, next question. If a square plus b square is 7ab, prove that log of a plus b by 3 is equal to half of log a plus log b. If a square plus b square is 7ab, prove that log of a plus b by 3 is half of log a plus log b. Try doing this. Now use small hint. In the given relation, try with a plus 20 on both the sides. A square plus b square is 7ab. Try with plus 2ab on both the sides. Done? Okay, see it. Good, great. Right. So as I said, if we add a 2ab on both the sides, what does it end up becoming? A plus b whole square is equal to 9ab, or that's like saying a plus b is 9ab to the power half. Or you could keep it as a plus b whole square as well. Whatever. So if we now start with the left hand side, log of a plus b by 3. Okay. This is like writing log of a plus b minus log 3. But what is log of a plus b? 9ab by e to the power half, just like half log 9ab minus log 3, or this is half log 9 plus log a plus log b minus log 3, and log 9 is like writing half of 2 log 3 plus log a plus log b minus log 3. So अब ये वाला part will cancel off with this part, will give us the required value half of log a plus log b. Yeah. Isn't that bit clear?
Log 9.
क्या चीज?
Log 9.
दो बार log अरे log a है भाई. Okay, next. So is everyone okay with the first set of properties and how do we use them for problem solving? Right? The basic idea. Okay. Then we go to the next set of properties. Next topic. So the next topic is base change formula. The next topic is base change formula. Now the base change formula is so suppose we are given log of a number b to the base a. Okay. And we want to change the base of the log to something else. Okay. Like a is a number that doesn't really suit you, so you want to change the log, the base of the log to your lucky number. Okay. Whatever it means. How do you do that? So log b to the base a is equal to log of b to the new base, whatever c could be any number of your choice, log b to the base c divided by log a to the base c. The number to the new base divided by log of the old base to the new base. This is the base change formula. This formula will help us to change the base of a given log to any new value. Base change formula. Okay, let's try to understand this first then. Proof. How does this work? And even for the proof of this, we'll start the same way. Let's assume that this is x, this is y, and this is z. X, y, z ले लो for the proof. So, what is the exponential version of this? This would imply a to the power x is equal to b. What is the exponential version of this? C to the power y is equal to b, and इसका c to the power z is equal to a. But then if this is the value of a and this is the value of b, let's say we plug in both of them in the first relation. Okay. This is a, this is b, we take them from here and plug them over here. So what will we get? C to the power z whole to the power x is equal to c to the power y. Or that's like saying c to the power xz is equal to c to the power y. Or now again, the numbers are equal, the bases are the same. What must happen? Powers must be equal. So that gives us x is equal to y by z, which is what we are looking for. X equal to y by z. And then clear with this? So it's an important result, the base change formula. Now, a few results based on the application of base change. Log of b to the base a is 1 by log of a to the base b. Few important results or properties based off the base change formula. So we have log b to the base a is 1 by log a to the base b, which is like saying in a log, if we interchange the number and the base, the value becomes reciprocal. That's how you have to remember it. Interchanging the number and the base, the value becomes reciprocal. If we interchange the number and the base, the value of the log will become reciprocal. How do you prove this? Okay, log b to the base a. This is the left hand side. Let's suppose now we apply the base change formula and change the base to b. We are changing the base to b. If we change the base to b, what will log of b to the base a end up becoming? Log of the number to the new base divided by log of the old base to the new base. Okay, that is how the formula principally works. Yeah. This is how the formula principally works. Log b to the base a would be log b to the new base divided by log of the old base to the new base. Yeah. But then, what is the value of log b to the base b? 1. So this is like saying 1 by log of a to the base b. So if we interchange the number and the base, what happens to the value? reciprocal. The value will become reciprocal. Yeah. Okay. Next. Second property based on the application. If we have a number raised to the power the log of the same base, a to the power of log b to the base a to the power of log b to the base a, this becomes b. This is we refer to this as a number raised to the power of log of the same base. They cancel each other's effect. Okay. They cancel each other's effect. Okay. As a proof. Suppose we take log b to the base a is x. Suppose we consider log b to the base a is x. What is the meaning of this? A to the power x is equal to b. This means that a to the power x is equal to b. Now let's suppose we start with the left hand side. What's the left hand side over here? A to the power log of b to the base a. But what is the value of log b to the base a? Log b to the base a is x. So this is like writing a power x. This is like writing a power x. But what is a power x? B. So this is equal to b. If there are any confusions, I'll just show you this with an example. Suppose we have log 5 to the base log 625 to the base 5. This is what we mean by a number raised to the power log of the same base. Yeah. How will this function? Log of 625 to the base 5 value 4. So this is like writing 5 to the power 4. But 5 to the power 4 फिर से क्या हो जाएगा? 625. Yeah. The idea is, how do we define a log? The log of a number to a given base is the exponent by which the base must be raised in order to get the number. And यहाँ पे तो same ही base है. So whatever is the value of this log, जैसे मान लो this comes out to be x. So what will that imply? That if we raise 5 to the power x, we get 625. Okay, now we have the entire log over here and log represents the exponent. So aren't we just raising 5 to the same exponent? ये तो कर रहे हैं. This is like 5 to the power the exponent, which will give us the number. So what will we get out of this? The number. So a number raised to the power log of the same base will give us the number. The number नीचे आ जाएगा. Is that okay with this? If we have a number raised to the power log of the same base, they cancel each other's effect. They cancel each other's effect. Okay. Next, a to the power log b to the base c. अब base same नहीं है. The base is a and the power is c. Now they are not the same anymore. So now the property over here is, in an expression of this form, the number in the base and the number inside the log are always interchangeable. Okay. So this would be like writing b to the power of log a to the base c. The number in the base and the number inside the log are interchangeable. We can easily switch between the two. We can always switch between the two. Proof. Okay. We start on the left hand side. A to the power log b to the base c and apply a base change to the log. Base change to a. So if we change the base to a, what is the resulting expression? Yeah, I got log of the number to the new base divided by log of old base to the new base. Yeah. Okay. Now in the next step, can we rewrite it as, or rather, can we restructure this as a log b to the base a whole to the power 1 by log c to the base a? Well, basically what I am doing is, if I have a to the power m by n, can we write it as a to the power m whole to the power 1 by n? Look at it, no? This is basically what we're doing. We have a to the power m by n, so we can always write as a to the power m whole to the power 1 by n. But then what will happen to this part? Number raised to the power log of the same base, you know. Number raised to the power log of the same base will become b. B will drop down. So this becomes b to the power of 1 by log of c to the base a. But what will be the value of 1 by log c to the base a? The value is in the reciprocal form. How can we adjust it? One by log is in the reciprocal form. How can we adjust it? By interchanging the number in the base. Okay. अभी इसके पहले जो property किया था, what is it? If we interchange the number in the base, what happens to the log? The value becomes reciprocal. So if the value is already reciprocal, how can we adjust it? By interchanging the number in the base. So इसमें number in base adjust कर दो. So this becomes b log of a to the base c, which is the right hand side. Okay. Is it okay with this part? So this would be like, is that done with this? Okay, so move on. Okay. So this would be like saying, suppose if we have an expression of this form. What is the value of this? The base and the number in the log, inside the log, are interchangeable. The number in the base and the number in the log are interchangeable. That is how we will apply the property. So if we interchange them, what will this expression become? 7 log 5 to the base 3, and ये तो already 7 log 5 to the base 3 है ही है. So what do you end up getting? 0. Does anyone get the idea of this? समझ आ रहा है how is things happening? Right? For a number raised to the power log of a different base, The number in the base and the number inside the log are interchangeable. You can always freely interchange them. And it helps in a lot of calculations, right? Like for example, suppose we are given something like this: 9 log 5 to the base 3. What is the value? Now, log 5 to the base 3 cannot be computed. 3 के पावर में 5 आएगा? आएगा, but it will not be an integer. Okay, it will not be an integer. It will be some irrational value. So what we do is, what would be a better mode of calculation over here? We interchange. इसको interchange कर दो, because 9 is more confirmable with 3. Okay? 9 is a more convenient value to have with 3. So 5 log 9 to the base 3. अच्छा ये तो directly 2 हो गया. So what do we end up getting? 25. So these will be like small observations that you'd have to make by between the numbers and the bases to visualize or to ascertain that okay, what would be a more comfortable way of solving the question. Okay. Can we match the numbers with appropriate bases so that they can be simplified a little easier? Is that okay with this? Okay. So let's move forward. Let's solve a few more questions. Okay, next question. Find the value of log 11 to the base 3 into log 13 to the base 11 into log 15 to the base 13 into log 27 to the base 15. Find the value of this. And for this question, there are a thumb rule. In a lot of places, while we are doing some problem solving, I'll make you write some thumb rules, I'll make you write some notes. So these would be like things that you need to keep in mind in order to be able to solve questions a lot easier. Okay. Generic methods of solving questions for the related topics. Right? For this, okay, for any question of logs, right? A question involving multiple logs, the thumb rule is the first thing that we do in these type of questions is ensure that all the log terms are to the same base. Okay. For all log questions, one of the first things that we do is ensure that all logs are to the same base. Okay. We make a check for this. सबसे पहले ये check करना है. If all of them are to the same base, कोई issue नहीं है. We proceed with the question. But if they aren't, then what should we do? We apply base change formula and bring them to the same base. Okay. Apply base change to bring all logs to same base if needed. If needed. Question में already अगर सारा same base है, क्यों छेड़छाड़ करेंगे इसका? Let it be. So now, in this question, we have 4 log terms. What are the bases of all the 4 log terms? 3, 11, 13, 15. All of them are different. So what's the first thing that we have to do in the question? We have to bring all the logs to the same base. Now that same base, क्या लाना है will be entirely up to you. That's the freedom that you have. Okay? That's the freedom you have. So, and then of course that will also be something that you have to decide by observation. That looking at the question, what would be a convenient value of the base to turn to? What would be a convenient value in this expression to turn to?
Log 11. Log is 3. Log base 3.
Let's go for base 3. We try to keep the base as small as possible. Generally, we try to keep the log value of the base as small because that can cater to more numbers. Okay, the smaller the value, more numbers it can cater to. So what we do is first step, base change. Base change to 3. सारे logs में base change to 3.
Is base A.
कोई भी ले सकते हो. Base कुछ भी ले सकते हो. Ultimately it's upon you to decide क्या लेके करना है. So if you change the base to 3, तो पहला वाला तो base 3 पे ही है. Let it be. अच्छा, what happens to this? Second वाला log के लिए log of the number to the new base divided by log of the old base to the new base. So this will be log 13 to the new base divided by log of the old base to the new base. Okay. And what about the next one? Log 15 to the base 13. What will this become? So this would be log 15 to the base 3 divided by log 13 to the base 3. What about the last one? So this would be log of 27 to the base 3 divided by log of 15 to the base 3. Now directly what happens? And this is why we make the bases same. सब cancel हो गया? Yeah. That is one of the reasons why we always try to keep the bases same. Simplifications happens a lot quicker, faster and easier. अब जो बचा है log 27 to the base 3 value 3. So the answer is 3. Okay, next. Question again, same है, find the value. Okay, the question is 81 to the power log 5 base 3 plus 27 to the power log 36 base 9 plus 3 to the power 4 log 7 to the base 9. What is the value of this? Value निकाल भाई, number give me the number. And the first one is almost direct. 27 to the base 9. What should we do for the first law? It's a number raised to the power log of a different base. What do we do? The base and the number inside are interchangeable. Flip them over. So we get 5 log 81 to the base 3. Now what do we log 81 to the base 3? 4. So here we have 5 to the power 4. Value 625. So the first term is set at 625. What do we do with the second term? Same thing. So we switch 36 and 27. So this is 36 log of 27 to the base 9. Now what we do with log 27 to the base 9? 27 can be written as 3 cube and 9 can be written as 3 square. So which property should be applied? P by Q wala? Power of the number will come out in the numerator, power of the base will come out in the denominator. Okay. Log of 27 by 9 is like 3 cube by 3 square. So 3 आ जाएगा numerator में, 2 आ जाएगा denominator में. What are we left with? Log 3 to the base 3. What will log 3 to the base 3? 1. So ये देगा 36 to the power 3 by 2. Now what will be 36 to the power 3 by 2? 216. 36 to the power 3 by 2 would be 216. So 625 plus 216. Okay, now the next वाले पे आओ. What should we do with the next number?
The 4 can be written as 7 to the power 2. 7.
Well, we can just treat it in each way, no? How much is 3 to the power 4?
80.
81. So can we write this number as 81 log 7 to the base 9? You know? Now what should we do next? Obviously, interchange. So we get this as 7 log 81 to the base 9. Now log 81 to the base 9. 2. So 7 square. 49. I think you should get the answer as 890. Okay, next. If log 2 to the base 7 is A, then find the value of log of 28 to the base 49. If log 2 to the base 7 is A, then find the value of log 28 to the base 49 in terms of A. Find the value of it in terms of A. Find the value of it in terms of A. So if we start with log 28 to the base 49, how do we simplify? Break the numbers into the smaller parts. Break the numbers into smaller parts. You see, what can we write 28 as? 4 into 7. But 4 into 7 is like writing 2 square into 7. And 49 ka what can we do? 7 square. Okay. Now what happens with the square on 7? Will come out in the denominator. So I have half of log of 2 square into 7. Now what can we do with log of 2 square into 7? 2 square into 7 is a product. 2 square into 7 is a product. So what do we do with log of a product? Split as a sum. So half of log of 2 square plus log 7 to the base plus log 7 to the base 7. Yeah. Now ये वाला 2 will jump out. ये बाहर आ गया. And the next, what will be the value of this part? Log 7 to the base 7 is 1. And what is the value of log 2 to the base 7? A given here. So what will be the answer? This is half of 2a plus 1. If log 2 to the base 7 is a, then log of 28 to the base 49 would be half of 2a plus 1. Is everyone able to understand how we are working things and how we are simplifying things? Log of properties be comfortable? Yeah. Okay. Then we move on to the next topic. After the properties, next topic. Log equations. Next topic would be log equations. How do we solve questions involving equations given in terms of logs? Solving log equations. We'll do this with the help of an example. Like suppose we have a question given in this way. Log of x minus 9 to the base 10 plus log of x to the base 10 is equal to 1. Solve for x. The question is, and we are asked to solve for x. Then the method, the usual approach that we take for this is solving log equation is step 1. List out the process so that it would be convenient to remember. Step 1. Ensure all the bases are same. Like we did in the previous part, every log question, what is the first step? कुछ भी कर रहे हो log के terms में, what is the first step? Ensure that the bases are same, because only when the bases of log are the same will we be allowed to use all these set of different properties that we have discussed today. Okay. All those properties are only valid under the condition that the bases are same. Only when the bases are same can we club logs, can we split logs, and do all those different things that we need to do for simplification. Okay. So step 1, ensure all the bases are same.
Here you have to find the value of x.
Of course, equation में करना क्या होता है? तो ये है. Okay. Again, now this is a log with base 10. This is a log with base 10. Log का base are same. That means we don't need to do anything special for the first step. All set it. Okay, step 2. Simplify the equation to get one log term on both sides. simplify the equation to have one log term on both sides. Okay, like on the left hand side over here, how many log terms do we have right now? 2. But how many do we need eventually? Only 1. So how do we convert these 2 log terms and bring it to 1 log term? We apply the property that log A plus log B would be log AB. So x into x minus 9 to the base 10. You get? Is equal to. Now we need 1 log term on both the sides. So left hand side to set ho gaya. How do we get 1 on the right hand side? The value 1 can always be written as log 10 to the base 10. Yeah, 1 we can always write as log 10 to the base 10, not an issue. So making this replacement will bring in a log term on the right hand side as well. Now once we come to this stage that there are only 1 log terms on either side, step 3. We take anti-log of both sides and solve for x. Take anti-log of both the sides and solve for x. And now taking anti-log in any equation would basically be like, if we want log of this to be equal to log of this, when will that happen? So we take anti-log. Anti-log is a step where we can remove log of equal bases from both the sides. Here we have log to the base 10. Here we have a log to the base 10. So when we do an anti-log, it will remove the log from the equation. So if we have log of this equal to log of this, taking anti-log will give us x into x minus 9 is equal to 10. Taking anti-log is the step of removing log, eliminating log. The process of eliminating logs is referred to as taking anti-log. अब ये क्या बनेगा? Quadratic. Solve करो. Solve the quadratic. ये तो कर सकते हो. यही फॉलो करना होगा. बस सीधा ऐसे करना है तो ऐसे ही देगा. n and 1. क्या है? -1 and 10. Okay. So solving this, you would get x is equal to -1 and 10. Now, once we have the values of x, we have solved the question. Then comes in the most important step. Step 4. Okay, the question is not done yet. X का value निकाल के कुछ मत हो. Picture अभी बाकी है. Things are not going to be so simple. Step 4. Next. Verify the values of x for validity with the original equation. Verify the values of x for validity with the original equation. Now, What we basically have to do it in this particular step is we have two values of x, -1 and 10. Now we take these values and put them back into the original equation. Let's see. If we take -1, put that over here. ये क्या बना? Log of -10 to the base 10. Yes. But is that okay? जरा सोचो. If we have an expression like this, 10 to the power x is equal to -10. ये तो हो गया ना यहाँ पे. Log of -10 to the base 10 is like we need a value of x for which 10 to the power x can become -10. Find x. Can 10 raised to the power of anything become a -10? बोलो सोचो real numbers में of course we are talking about real numbers. Your 10 is a positive number. 10 is a positive number. A positive number raised to the power of any real number will always be positive. 10 to the power any real number can never become negative. Okay, so that means that whenever we have a log, the value inside the log must always be a positive number. Okay, when we say that we have to check for validity, तो check करना क्या है? What do we need to check? We have to check that the value inside the log is positive. Logs are only defined for positive numbers. ये हमेशा verify करना होगा. In every question for logs that we solve, you always have to verify the solution. Logs are only defined for positive numbers. Log of a negative number is not defined. Okay. Log of a negative number is not defined. So since using -1 we get a negative number inside the log, it implies that -1 is an invalid solution. नहीं चलेगा. It has to be rejected. Although on solving the equation we are getting x as -1, but x equal to -1 is an invalid solution. It's an invalid solution, hence rejected. Okay. The proposal of x equal to -1 is rejected. नहीं होगा ये. Is everyone okay with this? Is the reason clear? Why we need to reject it? Any positive number raised to the power of a real number can never be negative. So we have to always ensure that the value inside the log is a positive number. Logs are only defined for positive numbers. What's up with 10 then? 10 को करेंगे क्या? 10 minus 9 1 पॉजिटिव नंबर है, कोई इशू नहीं है. यहाँ पे 10 पॉजिटिव नंबर है, कोई इशू नहीं है. So this is valid. This is valid. So what is the answer of the question then? 10. Only 10. X equal to 10 is the only solution. Here, does anyone have any confusion with regards to the steps of solving the log equations? Can I ask you what we need to do for every step? Yeah. Okay, then let's try out a few more questions on this then. Alright, solve for x. Log of 5 to the base 10 plus log of 5x plus 1 to the base 10 is equal to log of x minus 5 to the base 10 plus 1. Solve for x. First step, ensure star log service is given. Yes, there is. Move on to the next step. Get one value, one term of log on both the sides.
As soon as you get the log of negative is 10, you look at undefined. Okay, it cannot be multiplied with any other number. Multiplied by plus minus multiplication with 3 over 10 is 10.
Log 1 is now. So 1 is now. Log 10 to the base 10. Not 0 to base 10. 10 to the base 10. So that will be x plus 5 into 10. X minus 5 whole into 10. So we can consider it. Right. Now, simplifying, this would be log of 10, 5 into 5x plus 1 is equal to log. Achha, what do we do with this 1?
Log 10.
Log 10 base 10. तो यहाँ पे club हो गया 10 into x minus 5 to the base 10. Now one log term on both the sides, we do the step of anti-log. So taking anti-log, क्या देंगे था 25x plus 5 is equal to 10x minus 50. What do you get for x? Minus 11 by 3. So we do get this as x, but it's not necessarily the final answer. Okay. What is the next step that we need to do? Verify. So we take this. अच्छा इसी में डाल दो. If like x has minus 11 by 3, minus 11 by 3 minus 5 will be a negative number. Okay. Is log defined for a negative number? No. So what happens to this? It's an invalid solution. So what is the answer to the question then? This equation has no solution. Okay. This equation has no solution. That will be the final answer. The equation has no solution. Okay, let's try a few more. Question. Log of 8x minus 3 to the base x minus log 4 to the base x is equal to 2. Find x, solve for x. Log of 8x minus 3 to the base x If you notice in the question, we have x in the base as well. You know, we have x in the base as well. So, well, you can actually go ahead, go back. Go back, come back to this condition. This is a small modification. So, in the verification step, if x is in the base may be head, then there will be one more thing that you have to verify, which is the value inside the log has to be positive. एक और condition लग जाएगा, the base of the log has to be positive and cannot be equal to 1. You have to check for these two things. Numbers and base में भी, अगर x base में है तो you also have to make the check for this. The value of the log, the value inside the log has to be greater than 0, and the base of the log is greater than 0 and cannot be equal to 1. Okay. Since there is the x in the base as well, तो ये भी चेक करना होगा. You also have to check for this. Again, how do we start? So this is like writing log of 8x minus 3 by 4 to the base x is equal to, what do we do with this 2? Log of x squared to the base x. You know, 2 को we replace as log of x squared to the base x. Now, what is the next step? Anti-log. So, anti-log will give us 8x minus 3 is 4x squared. Solve the quadratic. दो वैल्यू आएगी ना? x equal to half and 3 by 2. ये आएगा दो वैल्यूज. ओके, बाकी सभी कर लो. हाफ एंड 3 by 2. मिलना फैक्टराइजेशन हो जाएगा इसका तो 6 and 2. 4x में minus 8x plus 3x, 6 and 2. मिलना फैक्टराइजेशन हो जाएगा. ये 4 कहाँ से आया? ये वाला 4 इधर क्रॉस में लेके गए तब 4x स्क्वायर होगा ना. Is everyone able to reach till this step? Sakare, half and 3 by 2. Okay, then we start the verification step. Okay, x is equal to half. If we plug that over here, 8 into half, 4, 4 minus 3, 1. Positive है, not an issue. Base में x equal to half, positive है, not an issue there as well. So half is valid. Again, 3 by 2. If 3 by 2, so whatever, 12, 12 minus 3, positive, यहाँ पे भी positive. So in this case, both the values are valid. So x equal to half and 3 by 2, both are valid. आपने क्यों इतना लिखा क्या? Greater than 1 नहीं, greater than 0 चाहिए, positive, positive. Okay. So for this particular case, both the values are valid, half and 3 by 2. Okay, next. Log of x to the base 16 plus log x to the base 4 plus log x to the base 2 is equal to 14. Find x. Log x to the base 16 plus log x to the base 4 plus log x to the base 2 is 14. Find x. How do we start in this? We'll have to make the bases same. Okay, the bases are not all same. 16, 4, 2. So how do we make the bases same? Well, two ways. We could either apply the property that, well, 16 would be like 2 power 4, 4 is like 2 square, and then take the powers out in the denominator. Right? Or the alternate way of doing it would be we can take the reciprocal values, switch the base to x. Okay? But doing the first part would be more convenient. So what can we do with this 16? 16 is 2 to the power 4. So can we say that this is like writing 1 by 4 log x to the base 2? What are the next term? Half log x to the base 2 plus log x to the base 2 is equal to 14. So log x to the base 2 commonly we simplify to. So log x to the base 2 taken common, bracket में आ गया 1 by 4 plus half plus 1 is 14. How much will be this? 7 by 4. So 7 by 4 times log of x to the base 2 is 14. ये cancel हो गया, ये इधर चला गया. So log x to the base 2 is 8. Now if log x to the base 2 is 8, how much would be x? If log x to the base 2 is 8, how much would be x? 3. Right, what's the definition of log? Finally, thank you. 3 to होगा. अभी what were we discussing throughout the log? Log of a number is the exponent to which the base must be raised. X is 256. 3. You are okay with this? X being 256 and not 3. Okay. Onwards and forwards. Next question. If 1 plus log of x square plus 1 to the base 5 is equal to log of x square plus 4x plus 1 to the base 5, solve for x. Solve it the same way as with the previous questions.